How's it going, everybody? And welcome to our last and final video when it comes to the VCA DCB, or VMware Certified Associate Data Center Virtualization exam. In this particular video, we're going to take a look at just a couple of different features when it comes to the way that networks and VMware work. So the first thing that we're going to take a look at is storage and virtual networking. What is that and how it works? Then we're going to come down, once we break down storage and the different aspects of it, then we're going to get into the networking, and then we'll wrap it up at the very bottom here with a little bit of finishing up and how networks work with inside of vSphere. So without any further ado, let's get started. Now, from a high-level overview, and this is all going to be high level. We're not going to get into any of the dirty details about how this stuff works. In the next video series, we will get that kicked off and show you guys how it works. And what I actually do is, I've actually got this video series started, is I spin up a vSphere environment and I get a couple of servers running. I show you how to install vSphere. I show you how to install ESXi into vSphere. I show you how to get the Windows environment running and start bringing things into play, things like that. But that's for the next video series. So we have shared storage. Shared storage is the ability to give two or more computers, that's supposed to be a P there, computers or VMs access to the same storage device. A NAS, for example. Now, what is a NAS? Well, let me explain. Okay, well, here's what we have. We have an ESXi server. This could be a blade server, where a blade has a chassis, or a blade server basically fits inside of a chassis, and there's multiple blades that actually plug into it. You know, they can be taken out, put in. A rack mount server, like what I will be running our ESXi servers off here in our lab, is just a single 1.7 inch tall, 19 inch wide server that's running two Xeon processors and 24 gigs of RAM. 24 gigs of RAM. So that's what we're going to be running on, and I have 250 gig of onboard storage, onboard shared storage, and I'll talk about that when we get into that a little bit more. But we have the ESXi host, and this guy right here has got 4 blades into it. So we have blade 1, blade 2, blade 3, and blade 4. Now, over here, we have a direct connection to a NetApp or EMC storage array. The storage array could be a NAS for network attached storage. It could be a SAN for storage area network, or if you're really good at what you do, you can make it look like as DAS, direct attached storage. Now, let me just take a couple seconds and explain what NAS, SAN, and DAS are. NAS, if you have a computer, and let me give you an example of it from here. This is actually my physical server that I have. This is the IP address of it. So what I'm going to do is I'm going to map a network drive. Okay, so I'm going to click on Map Network Drive, and I'm going to say it's going to be the Z drive. So I'm going to whack. I'm going to go to my computer, which is the one I'm recording on, and I'm going to hit N and hit Enter. So what it's going to do is going to attempt to connect to my computer on the N drive. What this is basically doing is it's going to use the network to go to a shared storage somewhere on the network, or what they call a network attached storage, a storage device that is, and there it is. So if we were to click close on this, now it's here. So I have 520 gigabytes free on my 2 terabyte external hard drive. This is my external hard drive. So, tapping on it. So, what ends up happening is, this is what you would connect to. This is what they would consider a NAS. Because of the fact that you use a network file share, or NFS, network file system, to get there. So I went whack, Riker PC, whack, and then I typed in N. So right now, I named it N. It's actually got the Z drive locally on this server, but that's how I would incorporate that into my network. So that's a NAS. A NAS is going to use a whack server whack, share type of connectivity to get to where it needs to go. If you advertise this through a group policy to a computer, it's going to be a NAS because of the fact it's got to use the network to get there. A SAN is a storage area network, and what you basically do with that is you have a NetApp or EMC or a storage array, and what you do is you load up the storage appliance. Sometimes it's called API or Application for Programmability Interface. You use a storage API or a storage interface. And what this interface does is it gives you the ability to take all of these disks that you see right here. So this disk, this guy, and this guy. It allows you to take these disks and it allows you to advertise them to a particular set of ESXi host, ESXi guest operating systems here on this ESXi host. So you're able to advertise this guy. Let's say this guy right here is a 1 terabyte SAS drive spinning at 15,000 RPMs. Okay, that's the type of disk it is. So you advertise this disk to Blade 3 right here. So when Blade 3 opens it up, and they open up my computer, it's going to show up. We're going to have C drive, and we're going to have D drive. Let's make that a bit bigger. We're going to have, you open up my computer, you're going to have C drive, D drive, and then you're going to add in, that's going to be the line, to separate local, and you're going to have, maybe have G drive. The G drive, which is going to look directly attached, is actually going to be using the storage network. It's going to still use the network to get where it needs to go, but this is going to be high speed, maybe 1 gig or potentially 10 gig connection. And this is going to allow you to use a fiber channel or an iSCSI type of connection to connect back to your NetApp or EMC array. And it allows you to advertise this storage array right here to this particular blade, to a particular guest operating system. It looks like it's directly attached. That's the idea of a SAN. And you can sit there. The major difference between a SAN and a NAS is the way that files are delivered to them. A NAS, this is block level. This guy right here is file level. File level means you can drill down. So you're going to have folder. Well, let's say we'll do this. It'll be easier to understand. We're going to do share. So you're going to do the N drive. Then you're going to drill down. You're going to double click on that. Then you're going to have a bunch of folders inside of that. So the folder, and then we're going to have, say, OSs, operating systems. Okay. Then you're going to drill down a little farther, and you can go to the file level. And then you're going to have MS Win 7 Pro SP1, and that's going to be the file name. So that means that you're going to go to the N drive. You're going to drill down to the operating system folder, and you're going to pull out the Windows 7 file, the ISO. And then you're going to be able to deliver that. You might point a guest operating or an ESXi host to, if they want, instead of keeping the operating system local to the ESXi host, you can simply use the NetApp array to hold that same operating system on the storage array, and then the ESXi host can boot from SAN. It can boot from SAN and then pull this operating system and then boot it to the ESXi host. And then the guest operating system can utilize the network in order to do all of its transactions. So it makes it very scalable. Now, a DAS, or direct attached storage, is going to be, if you were to open your computer and you've got your spinning 3.5-inch SATA drive, it's spinning at 5,400 RPMs, or you open up your laptop and you got your 2.5-inch solid state hard drive from out of your MacBook Pro or whatever, that's going to be direct attached storage. It's physically plugged into the computer. Now, technically speaking, my external hard drive that I just mapped to my server a minute ago, that's actually direct attached storage to my home computer, my computer I'm tapping in right now. That's directly attached because it's a USB connection to the back of my computer. Now what I've done is I've shared the drive. Pull this open. I've shared the N drive. So if I double click on it, well, if I actually come here and then go my computer, here's the end drive. It's an external hard drive. So I've shared the drive out to the rest of the network, and what I've done is I have to actually right click on this. If I go right click and I go properties and I go sharing, computer needs to take a second to add. I don't do this every day. Well, anyway, I wasn't going to wait for that to respond. But as you can see right here, what I did to my Windows system, Windows server over on my server, is I shared the hard drive here. And what I did is I went into here and I went to advanced sharing, and then I clicked on share this folder, and I went add, and I went permissions, and I added everyone to it so that everybody that's in my home network here could have full control over the hard drive. No one's going to play with it, but it gives them the ability to go in and share things to it. So if I was to double click on here, there's not a whole lot going on. You know, you got me, the administrator, and then we have, various folders in here. But as you can see, we have the share, then we have the folder, then we have other folders, and then we have other folders, and then we have virtual machines, and then we have my folders. So right now, this is how my home network, or the virtual machine environment, is set up. So if we were to double click on here, then we have all the virtual machine information for this. We click up here to this guy, same thing with this guy. There's all this information stored on here. So these are all the shares, 2 gig, 2 gig, 2 gig. What I do usually when I set up an ESXi server, or a VMware, or a VM, I usually split the disk into smaller partitions. I'm going to stop doing that because it's easier to thin provision than it is to thick provision. And the difference between those two is actually very, very simple. Okay, then it finally woke up. Yeah, just move that off to the side here. And pause. So, what that basically allows you to do is it allows you to drill down. Just restarted itself. It allows you to drill down and get very specific as to what's going on. So, that's the difference between all that. Now, we come down here and we look at storage types. We have vSphere supports fiber channel over Ethernet, iSCSI, and NFS. We already talked NFS. We've talked a little bit about SAN. We talked a little bit about NAS. So, with these guys right here are typically found in data center. Well, actually, all of them are usually found in data centers. But fiber channel and fiber channel over Ethernet, those are typically used with your high-end, with fiber optic cabling between your host computer or the host server, and typically a storage array for high-speed throughput, usually 10 gig connections. I know the Cisco Nexus 7000 series switches, they support like 40 gig fiber channel. So vSphere also supports local storage, which is going to be your local data store on your computer. So it's a component, then we also have the vSphere storage appliance, which is a component of vSphere that allows you to create shared storage from the local storage on the host. Provides the management and control to share these local storage devices so that you can take advantage of distributed resource scheduler, high availability, and fault tolerance. You designate disks within your ESXi host, and VSA takes care of the rest. VSA intelligently replicates data between the ESXi hosts so that if one server fails, you keep running. VSA is cost effective in the enterprise where it can provide branches with storage capabilities. You can essentially manage the VSA installations throughout your vSphere web client. So let me just touch real briefly on that. So if we were to take and get rid of all this, and go back over here to... So we have an HQ right here, and then we have all these. Well, let's say for a minute that we have connections down to a, looks like a shoe. You have an MPLS cloud that you're running with, and you have a variety of remote sites that you connect to. So this is HQ. We have Site 1, Site 2, Site 3, Site 4, and Site 5. So what you're basically doing is all these are branches, and they have a real small. They might have a real simple server there with, maybe 20 to 30 users, and maybe they have read-only domain controller on site, and maybe they have a real basic instance of AD on site for logging in and things of that nature, where anything email or storage-wise is actually shuttled up through MPLS to the HQ, so that HQ is able to take care of all the replication. So if something happens up here on one of your ESXi hosts, this information is able to be sent to all these locations simultaneously. Gives you a lot of flexibility. Also, some of the other flexibilities that come into play with fault tolerance and can allow, if say Site 1 suffers a major disaster, the building catches on fire and burns to the ground. So you have all these servers, right? All these servers are on site and running all these applications, and you have your, kind of goes off to a LAN segment, and you have a bunch of users that are no longer able to they're not up and running anymore. Well, what you can do is you can take these same connections. You can tell them to connect. You can tell your users, via, company email, or, you call them directly and say, okay, you guys are now going to be able to remote into, you can go to this URL, say, hq.company.org, and from here you're going to enter your AD username and password, and instead of having to physically go to the site, you can allow them to spin up VDIs on your ESXi hosts and either potentially run Citrix servers and allow them to do VDI across the WAN connection, or connect through the internet through an SSL VPN. Something to that effect. These are all flexibilities that you get when you're dealing with ESXi, because it's something that allows you to provision a server extremely quickly. So, VFlash, you can leverage internal SSD drives to accelerate the read performance of your VMs. This can take some burden off the SAN because VFlash operates like read cache. You need at least one SSD or solid state drive in your ESXi host, and they configure the VM to use VFlash storage. Data stores. These are just logical volumes that allow you to organize the storage of your ESXi hosts and VMs. You can upload and download files within the vSphere web client. The types, you have virtual machine file system and network file system. VMFS are local iSCSI fiber channel FCOE, and FS built from connections like NAS. And I just gave you an example of what NAS would look like. So let me show you what a data store would look like. And scroll down to it. You would not know that I'm actually using a pen to do this. So let me pull up ESXi, which I've had running now for a few days, steadily. So this right here is a data store. This guy right here. Right now, I have approximately 21 gig of RAM that I can allocate to this box. Right now, 7,500 gig is in use. So that's a combination of being used from the host Server 2008 box that I've got running, and the two servers that I have running here. We have a Server 2008. This is just a member server. This is actually my vCenter server right here. This is the server that I have vCenter installed on. And then we have the domain controller. So I have already shot the videos for how to get these up and running and how to get them into the same domain and things like that. So that's already set and ready to go. But let me just show you how this data store works. Right now I have 132 gigabytes available to it, and 53 are available. So basically what you could do is you can go right click on this guy and go down to Browse Data Store, and what I did is I uploaded Server 2008 R2. Now I don't have to upload this to the server. I can actually go in and set up a way for these guys to boot from SAN or boot from NAS and use local storage on my N drive, which is located on my computer, to connect into to boot an image from. But for the sake of speed and ease, I uploaded the ISO to the local data store, and then I'm able to boot from that. So what you're actually able to do is when you go into here, go to settings, and you go to CD drive. I've actually got a boot data store ISO, so you can connect down to some other device, or you can use the host device and you can specify where you want it to go. But I never do this. I've always used the data store ISO because it's easier to do that. We will look at this in more detail when we get into the VCP level. This is more VCA level. So that's how you would do that. Now the networking aspect of it's actually pretty simple. So let me drill down a little bit to this. So we have virtual networking. So for each VM, an ESXi host on the network has an address and a virtual network information card, or network interface card, I should say, VNIC. These hosts and guests are connected to virtual Ethernet switches, just like in real life. So in real life, you're going to have. Let me get rid of this real quick. Just in like in real life, you're going to have a switch. Could be anything, or I'm just going to draw an arrow this way and an arrow this way, with several ports connected to it. You have several users, and normally switches are not drawn like this, or looks more like a CPU socket than anything else. So you have all these switches. You have the switch right here, and then you have an uplink to potentially another switch, or maybe a router. So we have a R1. So this is switch 1. We have R1. So what ends up happening here is inside of the vSphere, you're able to take this logical switch and you're actually able to separate, just like in a real switch, each port into a VLAN. So you can say this port's in VLAN 2, this port's in VLAN 3, this port's in VLAN 4, 5, and so on and so forth. And then you would end up setting up a port here as a trunk. This is where the networking side of me comes out, and you're actually able to set these up so you can have all of the VLANs that you've got ports inside of trunking across here. So realistically, all the traffic is still traversing this guy, but they're tagged as this. As soon as they hit this as soon as they hit the trunk interface, they're tagged with whatever VLAN they're coming off of. So if they're coming off of 10. There's going to be and you have to use .1Q encapsulation for this because ISL is not supported outside of Cisco implementation. So there's actually a 4-byte .1Q header. Tag is actually what it's referred to. And you put this in front of the MAC address information. I'm sorry, just behind it. And what that does is as soon as it tags it, the router receives that traffic in and says, okay, you're for VLAN 10, but your destination is some other subnet. So he's going to send it back out, and what that's going to do is he's going to tag it for, say, VLAN 20. And then he's going to send it out here. This switch receives that, places it on the VLAN 20 VLAN in the MAC address table in Spanish tree instance, and then sends it to VLAN 20. So 20. And that's basically how inter-VLAN routing would work with the VLAN with the vSwitch. Now you would just have to physically connect to ESXi, and if you were to go to configuration and click on networking, you would be able to see that I have all these switches set up here. So I could go properties and I could go in here and start adding things, network adapters and things like that, and go edit and auto negotiate. I could set the speed and duplex if I wanted to. Click OK. And then if I wanted to, I could remove it, which I'm not going to. Now, it's connected. It's supposed to be this speed, but it's not, because the fact actually the VNIC does connect in at gig. It's other ports and stuff like that that come into play where you could do other things. So this is the VM management network, that's this guy. So, but I'm not going to go too much more deep into this because this is going way outside of what you're supposed to be able to understand about networking inside of VCA. So, bring this guy back up. What are virtual switches? VMware was able to turn physical switches into software switches the same way they were able to virtualize computers. VMs must have proper addresses and protocols. So what they've done is they've been able to take that same software that runs on a switch, Cisco switch or Cisco router, and they've been able to take that software feature and put it into VMware. So you're able to separate traffic and things like that and put in different things. It gives them a lot of flexibility. So you're still going to have all the normal things like spanning tree and things like that. You just have to be careful when you're dealing with networking because you can hose things up pretty quickly if you don't know what you're doing. And I've seen plenty of people that don't know what they're doing. Virtual switch types. vSphere supports two main categories of virtual switches. We have the standard switch, which provides basic connectivity and management features. And then we have the distributed switch, expands this and provides central management to different connections. Now for networking features, too far. We have VLANs provide logical separation of your networks. Traffic shaping is a feature that allows you to restrict in or out on network bandwidth. So we'll talk about shaping. Shaping, technically speaking, is always going to be an outbound, especially when it comes to networking. So let me click on this. Shaping, basically what you're doing is, let's say for instance you have an ISP, and then we have your connection down, and then we have your router. Okay, so let's say for instance the ISP is giving you 10 megabits per second. Shaping, your router here has gigabit, gig 1/0 interface. So the incoming interface, this guy right here, is going to try to send at 1 billion bits per second. That's what his serialization rate is going to be. So how fast you can put bits on the wire. So he's going to try to send that. And let's say that for the sake of argument that this router, R1, is actually capable of forwarding at gigabit speed. Some are, some are not. So what ends up happening is, as soon as these packets end up hitting this interface, they have to go from 1 billion bits per second down to 10 megabits, or 10 million bits per second. That's a significant drop in speed. So what you end up doing is you actually take this and you shape it. You say, I'm going to shape it, so I'm going to take this guy down here. You draw a funnel with an opening, and traffic coming in here into the funnel, comes into the funnel, and it gets slowed down. It actually gets buffered or queued. It gets buffered and queued. Now, the queuing, we're not going to talk about a whole lot of queuing in here because that's a quality of service feature. But what queuing does is it allows you to slow down the output rate down to a set limit. This is what they call the CIR, committed information rate. The committed information rate is how fast you are able to send to your ISP before your ISP will start dropping traffic. Now, in most cases, the ISP is policing. Policing simply means that if it detects more bandwidth coming in than what the interface is configured to handle, it'll start dropping packets. So, now, there are ways that you can do what they call the peak information rate, which is a burst. Which burst simply means if you don't utilize 10 megabits per second for the entire second, whatever's left over, so let's say for instance you only average 9 megabits per second for that 1 second, that means that you have the ability to add up a half of megabit for the following second to come by to actually add more bandwidth to it, as long as that half a megabit of bandwidth of data does not exceed the 10 megabit threshold on the interface. So in simplified terms, if you sent 9.5 megabits 1 second, and then you basically had a half a megabit of data bandwidth or of data banked. What ends up happening on this interface, or with it when you're sending, is if the following second, if you're still not going to break 10 megabits per second, you're able to take that half a megabit of data and you're actually able to add it to the following second. And so in the following second, you might only be sending 9 megabits per that second. What you'll be able to do is you'll be able to take that half a megabit you have saved and add it to the following second, so the second later, and you're able to send it out the wire as long as your total committed information rate does not exceed 10 megabits. Now, this is the peak information rate, and then we also have the burst excess, or the BE. The BE rate is simple. How much available can you actually send in a clocking sequence? Now, typically the way that routers send, they don't send on a per second basis. They actually take this and they break it down into several individual things. I'm drawing a bunch of these out because that's actually what they do. They take it in, say, 125 or say 25 millisecond intervals. So each one of these is 25 milliseconds over and over and over again. So it keeps going down the line. What this allows the router to do is it allows the router to take a certain amount of bandwidth. So if you were to take this 10 megabits per second and figure out how much bandwidth they would have to divide by to get a certain amount of bandwidth per every 25 milliseconds to add up to 10 megabits per second. Does that make sense? So if this particular interval he was able to send, say, 64K, and then the following interval he's able to send 64K, so on and so forth until over the course of 1 second he's sending 10 megabits for that second. Now, if he sends anything less than that, that goes into the bank, and then from the following second, as long as he's not sending 10 megabits for that second, he's able to add things in here. Now, typically what's going to end up happening is it's going to be somewhere in this lineup right here that's going to bring that into play. If this particular interval right here, this 25 millisecond interval, he's only going to send 32K. So what you're able to do is you're able to take that half a megabit and actually add it to this guy right here, and that's going to fill this entire section up, this entire interval, and that's going to allow him to take that 32 and actually make it 64, so you can always maintain your committed information rate. Now, in most situations, the way that your ISP is going to do it is they're going to sell you 10 megabits per second. You're going to pay for a 10 megabit per second connection, but in reality, they're going to oversubscribe that connection, meaning they know that not every customer is going to send 100% of their bandwidth 100% of the time. So what that basically means is whenever you are not sending, they're going to take whatever additional bandwidth is available and spread it among other users. Now, this is assuming you're on an MPLS connection. If you're on a fiber optic connection, you're still going to have to share bandwidth because of the fact that the provider, their backbone, has a bunch of connections doing something to this effect, going around all over the place, and they have connections going every which way but left. And what this allows them to do is connect off to hundreds of customers and sell them more bandwidth than what they actually have available to give the customer. It's what they call oversubscription. And then during high bandwidth utilization times, so for instance dinner time, the beginning of the day, on a Friday night, things like stock exchange closing bell, things like that, where a lot of bandwidth would be used, they're actually able to use their policing capabilities to actually slow down the incoming rate and start dropping packets. Now, dropping packets doesn't necessarily mean it's a bad thing. Simply might mean that the ISP is being overburdened or oversubscribed for that period of time. Don't worry about it. It's not that big of a deal. But if you notice that you're getting a lot of TCP retransmissions, then that could potentially mean that your ISP is bogged down, and you might need to set up some sort of quality of service policy map stating from, say, 4 to 7 p.m. Monday through Friday, you actually slow your output rate down to, say, 7 meg per second. What that'll allow you to do is it allows you to buffer more, send less often. So that ability to take this information that you're sending to the ISP, and if you have too much being sent out the door, if the ISP can't receive what you're sending it's going to drop it. It's very, very simple. So if you slow down your forwarding rate to the ISP, that betters your chances of your traffic actually getting to where it's supposed to be going. So I know I went way too deep on that. So, and I do apologize. Networking is what I do for a living. I'm a Cisco guy. Studying for my CCIE, I get QoS and how all that type of stuff works. It's understanding how queuing and committed information rate and peak information rate and all that type of stuff, that's way outside of the scope of what you're going to deal with. Traffic shaping, I don't like the way that VMware words it, because shaping is always going to be an output to your destination. Policing is going to be an intake. Okay, so this is going to be out, this is going to be in. So this is out to provider, and this is going to be into provider. So what this basically does is, if you're going to shape, you're going to be sending. If you're going to police, you're going to be receiving. You can't shape in. You can't do it. You have to police in. So now, port mirroring gives you the ability to monitor a VM's traffic for troubleshooting or intrusion prevention. What is port mirroring? Well, very simple. Port mirroring, well, let's take this switch right here, for instance. If you have port mirroring, let's say, for instance, you have... here's an instance of an issue that I'm having at work currently. I have a user that on their laptop, so I'm going to draw a quick laptop here. On their laptop, they are... It's going to be a horrible laptop. I'm definitely not an artist. So on their laptop, they're running a Citrix client here on their desktop. Well, when they're on the wired LAN, okay, they're connecting back to a switch. When they're on the wired LAN, they can't get to the application that they need on the Citrix server. Okay, but when they're on the wireless LAN, so I'm just going to draw an arrow, and this is a wireless signal. When they're on the wireless, they have no problem. So I know they don't have a problem getting to the server because I can trace route from there. I can ping it from that computer. Everything looks fine. I can see traffic getting to and from there. I have Wireshark. This connection right here and this connection right here. They're the same up to layer 4. Okay. What I have to do is I have to take the port that her wired connection comes in on. Okay, so we'll say port 10. And I actually have to take all that information, still allowing her to do her job. I have to take that information and I have to send it to another port where my laptop is physically plugged into the switch. So I do what they call, in Cisco, it's called monitor session. Put monitor SESS, or what they call span, or switch port analyzer. I need to span the port from here to here and send all of her traffic to this port where I can analyze it with, say, Microsoft Net Monitor. And that'll allow me to monitor the traffic as it's coming through layers 4 through 7. 5 through 7. 5 is session, 6 is presentation, and 7 is app. So I want to be able to see what's going on layers 5, 6, and 7. So that's what I need to do, and I'll be doing that over the course of this week so that I can figure out why. And I've had people ask me, well, why do you think it's application? Well, because of the fact that I can get to the server. If I couldn't get to the server, it's a network issue. If I can get to the server and I can get to the login screen, I can log in with both I can log in both on the wired LAN and on the wireless LAN. I can log into the Citrix server, so I can log in, right? No problem. It's when I go to an application, so I double click on here, so I tap. I double click on this application and it starts to spin up, but then it bugs out partway through. So when she's doing that, that's when I need to be watching these captures, seeing what's going on to try to figure out where things are going goofy. So, but that's how port mirroring works. The last one we're going to talk about is QoS. You can prioritize your network traffic. So let me come back over here to the whiteboard and pause this for a second. So QoS stands for quality of service. What does that basically mean? Well, QoS is a way. There's a couple different ones. You have congestion. Let's just congestion management, congestion avoidance. We also have priority. These are the three most common things. So management is going to be queuing. If we have too much traffic coming in, how do we handle it? Avoidance is going to be weighted random early detection. So how do we prevent a queue from getting overfilled? And then we have priority. This is going to be voice over IP. So you can take a voice over IP phone is by default, if you're going to be dealing with IP precedence, is going to be 5, which is going to be critical traffic. If you're going to be dealing with DSCP, this is going to be EF, or expedited forwarding. Expedited forwarding is also going to be DSCP binary is going to be 46, which is backwards compatible with EF41. So I'm not going to get into all how the forwarding and the high probability, all that type of stuff. I'm not going to get into that. But priority, you can set different classes. So you have EF is for voice. You have AF, which is assured forwarding, which is going to be mission critical application. So mission critical apps. It's like Citrix, for instance. Anything VDI. Then we're going to have what they call best effort. Best effort is going to be anything that doesn't match assured forwarding. So this is going to be, you're going to give it some priority over what they call scavenger. Scavenger is going to be everything else. So say for instance if you detect BitTorrent, or you detect say Pandora Radio. So scavenger class is not guaranteed traffic, but if there's traffic available, it will receive it. Best effort is going to be things like email, FTP, things like that. So you have voice is going to be what you're going to give the most priority to. The reason for that is voice is typically very small, smooth traffic. Like the words that are coming out of my mouth, very small, very smooth in size and in flow. They come out small and they're usually pretty free flowing because of when I'm talking, there's a pretty steady stream of traffic coming out of my mouth. Now, data, on the other hand, and video are big and bursty. So typically they need to have large bandwidth and not as much priority. Now if you're a Cisco person, like I am, you're going to set the priority to be strict when you're dealing with voice. So that it gets strict priority. It's either going to have a IP precedence value of 5, or it's going to have a DSCP value of EF. If you're dealing with Cisco, EF is automatically going to be an EF41. The highest forwarding rate and the lowest drop probability. So there's other ones in here, but I'm not going to get into them. Your data and video, the next one's going to be down is going to be your interactive video, where you're doing some sort of telepresence, where that is going to bring into the fact of if you need to sit there and wave at somebody so they can see you and you're going to wave back, that's going to typically require the video. The voice is going to require this, but the video, the VDO or the Skype or whatever type of traffic that is detected by the router is going to be an AF41. So it's going to be almost as high, but not quite as prioritized as voice. Now, data, depending on what it is, it could be Citrix, it could be It could be some other type of mission critical application. If you're dealing with warehouse management, it could be AS400. It could be, whatever else you got running in your network. It could be a lot of different things. So you're going to, based on your network, you're going to give it priority. Now, how do you determine what's what? Well, on a router, you can use what they call NBAR, or Network-Based Application Recognition. What NBAR does is it takes a layer 7 look at traffic as it's going through the router. So you can type in IP NBAR protocol discovery at the interface level of a router, and you can do show this command right here, and then you can see what type of traffic is actually flowing through the router at the time. Now, most devices have a basic database that they compare this to, so that's how this information is determined. So eventually you'll see like HTTP, you'll see Skype, you'll see HTTPS, you'll see SSL, you'll see a bunch of different types of traffic going through. If you want to know more about those, or you want to have specific information available to you, you would need to download what they call a PDLM, which are a protocol database language markings. And what that allows you to do is, as it's seeing traffic come through, anything that's unknown originally, but when you install PDLM, if it sees this traffic and it has something to compare it to, then it'll go ahead and mark it. So it might be, say for instance, BitTorrent, or it could be Skype, or it could be H323 or 464. I think I'm right about that one. But it could see these types of traffic and try to make a decision as to what each one of those are. So, and what you would do in most cases with your markings, because you're going to want to mark when you're queuing, you're going to mark. What you're going to do is you're going to actually go in, you're going to set up a QoS policy, and you're going to say to match protocol, which is going to call NBAR. NBAR is going to say, okay, well, it's web. So what are you going to do with web? You're going to give it AF41. Or you're going to give, it's going to say, oh, it's voice. You're going to give it EF. And you're able to mark it based on that. So I'm not going to go into any of that, how it works right now, because of the fact that it's way outside of our scope. I just wanted to go into detail on how this works at the networking side, because that's my strong suit. So that's pretty much the extent of what's going on. If you have any questions, feel free to drop me a line. I will be uploading these videos tonight as soon as I get this one recorded, and I'm going to go ahead and set it up and get the what's the word I'm looking for? Get the playlist set up on my YouTube channel and have this ready for you guys to be able to view here in a little while. And then I will also follow up with the VCP videos as I'm going through those. I hope this has been informative for you, and I would like to thank you for viewing.